Okay. Just getting the stream started here. I gotta redo my titles and tags and everything, actually. Let's see what we can do, though. There we go, and then make sure the category is correct. I think that'll work. Okay, let's go live. Settings. Wow, that was weird. Okay. Threw an error and then fixed itself. Okay. Go. We're going up. All right, how's it going, everybody? Welcome back to the Inicus project. I am going to be switching gears completely tonight. Uh, Last time, and the 10 or so streams before that, we were building the Lego Millennium Falcon, the giant one, and now we're not. It's done. It's finally done, and it looks really cool. It's sitting over here next to me. And so the next thing is I want to start getting into some stuff that we're really planning on doing on this channel, which is engineering and designing things and just making cool stuff. And so I was talking about this in previous streams, and I think a good place to start would be to light up the Lego Millennium Falcon. Uh, I have a strip of lights here, and it's running right now, and it's really bright, so it probably doesn't come across that well, but they're working. I've proven all the hardware works, which was a good thing I did because it took me like 2.5 hours to get all the bugs worked out, just to make sure everything was working correctly, and uh, and that would have been really embarrassing to spend an entire stream doing that. So we got to figure out exactly how we want to light it up. But before we do that, we want to set this up in such a way that we can use it to not light not only this Lego setup, but anything that we decide to add lights to later. And so I'm going to be going through exactly how this works right now, and then writing some software to control the lights. So I've got that kind of pulled up here. And actually, let me move this off to the side and save this somewhere where it makes sense. Let's see here. Go up some folders. And we'll say this is the main. I don't know exactly how I'm going to break this down yet. So yeah, we'll see what happens. And let's get started. Let's make some cool stuff, and let's make this look really awesome and I guess, I don't know, dazzling and bright. And right now these LEDs are already kind of blinding me with how bright they are. I've actually had to turn some of my studio lights here off because this is just so insanely bright. So it just washes everything out. Um, let's see too how this works. I've made some changes to the setup Obviously, we're no longer just using the webcam view, but my background on my computer as well and all that. So, yeah, we'll see how it goes and go from there. All right. I don't know if there's any housekeeping things I have to do tonight before I get started. There might be a couple things. Here, let me message. And since this is an absolutely new setup, with the way the camera is and the background and all that, feel free to give me any feedback on like how this works, how it looks. If there's a better way that you think I should be doing this, because I want to make sure I get the best quality thing I can for you all. Let me just send out a couple messages to people. This just gets them to look at the stream and let me know if it looks good or not. Hopefully everyone's had a good Thursday. We got a couple viewers already. This should be interesting. I'm curious to see the best way or to try and figure out the best way to do this because, uh, sorry. Okay, there we go. Sorry, just trying to get all my housekeeping stuff out of the way. All right, cool. So I'm curious the best way to do this because I want to be able to update this pretty easily. I don't want to have to rewrite code anytime I change the light display since we're putting it on different things. Right now it's on this Christmas, red green thing, which I know is so bright that you can barely even see it. Um, but I want to be able to update it to just about anything without having to actually write software. So I need to make some libraries, a modular way of controlling this, and then eventually, write some software for my computer that allows me to reprogram it just by dragging and dropping some GUI things. And then eventually, once we get this all kind of working and all that, we want to test it by putting it in the Millennium Falcon, which is sitting down here to the side, and kind of light up the engines and the underside and make it look really cool. So we'll get started with that. Let me pull up a reference over here. I went looking through, there we go, sorry about that. Went digging through a bunch of libraries to try and figure out how exactly to do this, and it's a little weird. I'm going to unplug these lights and show you kind of what's going on here. So to start, I have this Arduino, uh, which looks pretty standard, but when you look really closely at it, you realize that it's actually not an Arduino, and there's a label on there, the XLR8, the Accelerate. And this is from a company called Alorium Tech, and it's an FPGA-based Arduino. So it functions and works just like an Arduino, but it's actually pretending to be one, and you can actually change some of the FPGA fabric if you want to as well. This is useful here because these lights that I'm using, these Neopixels, are notorious for being difficult to run with just basic Arduinos and low-powered microcontrollers. But with the FPGA, you can program a little block into the side that can run these and then leave the micro to do its own thing and just update that block when necessary. So basically, it's a long-winded way of saying it's more flexibility and runs faster, which is useful for this particular scenario. So I've got a strip of about 30 of these NeoPixels, about a meter long, and a way to program them here. And since this thing pretends to be an Arduino, we can program it in the Arduino environment, which you see before you here. And that's this thing. So I'm going to get started. I'm going to start writing some code and figuring out how exactly this works, testing some things just to make sure it's working properly, and then we'll start organizing it uh, and writing something that's a little more modular. And I think our goals for tonight will be to write the software so that we can control the NeoPixels and then include something in the software that allows us to control the color and pattern of the NeoPixels through the serial port. So then I can just send data to it from my computer and I don't have to change the code to change what the pixels are doing. Seems pretty straightforward. And yeah, we'll go from there. And then once that's kind of all proven and working, then in following streams, I'll be updating different pieces of that. So this should be interesting. How's it going, Beth? Did you notice how, since y'all are here now, how bright these lights are? They're just like insane. So I'll try and turn the brightness down some too, so we can actually see what we're doing, and so you all can see better because they blow out everything, and they're just like blinding me sitting here on the table. So it should be cool though. So let's get started. This company, Alorium Tech, actually has created this NeoPixel block in the FPGA and library. That's part of the reason why I picked it. I wanted to learn how to use this thing. And so they already have a library for it. So we can actually just include that. So we go up here to Tools, or actually go to Sketch, Include Library, and then down here we have the Accelerate NeoPixel. There it is. All right, cool. And then I'm actually going to put a note up here. All right, NeoPixel lighting system, just to keep some level of documentation. Arduino and I tend to do our comments very differently, so we'll see how it goes. Okay, cool. All right, we got to get a couple defines out of the way. I've connected the LEDs to pin number 6 on this particular board, so let's go ahead and define that. And then, actually, you know what? I'm not going to call it LED because there's already an LED on here. How about NeoPixel pin? Okay. And then, what else do we need to know? That's probably straightforward. We do need to know the number of NeoPixels, like the max. Let's just leave it at 30 for right now. And then, actually, we'll probably need a changeable value. Let's make it a 16-bit. Current length. All right, so that would be a value that we can update. Because like I said, eventually we'll want to be able to change these settings with the serial port. So we need to, we should probably start with just doing this to the max. So we need to make variables that store all this stuff. So if you aren't familiar with programming, the very basic of it, one of the things you can do is make variables like this. You know, this just stands for unsigned integer 16-bit. Basically, it's a number without a non-decimal number, just an integer. And it can't be negative. And I've named it current length, and I can change this to whatever I want. So right now I've set it to max number of NeoPixels, which you can see is this value up here, which is 30. And don't forget your semicolon to round everything off. All right, so now we need to set this up. We can use our NeoPixel library, and actually I believe I have to create the object here for it. Yep. Let me just label that, and then according to the documentation here, it's accelerate, or I guess it's just this up here. NeoPixel, and we'll just name this strip, because that seems to be a pretty common name. And then, all right, NeoPixel, and then we want to make this, the first argument is the number of pixels. The next one is the pin, so we know that's pin 6. And then the final thing is a couple of flags. I'm actually going to copy these over from the documentation here. All right, and so it's two flags here. And what this indicates, this first one, this Neo GRB, means that the data is sent to it in green, red, and blue. Uh, you may be used to most things, like on screens and stuff. You've done any programming before. Everything is RGB, right? Red, green, and blue. For whatever reason, the people who made Neopixels decided that green should be first and then red and blue. So when you send the data to the strip, you need to specify the red value first and then the green value first and then the red value and then the blue value. The second thing tells you the communication speed, 800 kilohertz. There are two types. There's 400 kilohertz Neopixels and 800. I have the faster variant here, so I need to specify that for this library as well. Okay, and then we probably need to make a buffer to store it all in. So let's go. We need to. This is going to be 32T. There we go, strip buffer. And we're going to want that to be our max length. Okay. And then for now, that just equals that. And then we'll set it up. We'll initialize it here. Okay. Cool. I think this works. So now our initialization code. This is where we're going to set up a bunch of stuff. And then the way Arduino works is kind of weird. Most C programs, you just have a main function. And then you build all your smaller functions off that. Oh, excuse me. So they have this setup function where you set things up to start with. And any kind of initialization happens there. And this function, the only thing that's really important about it is that it runs once and that it runs first. When you plug this device in, it's going to be the first thing that happens, and it's only going to happen once. After that, the next thing that happens is this loop function. This loop function runs after setup and then runs again and again and again to the end of time until you unplug the device. So you put your setup stuff here, the things that you need to get initialized, like pin configurations and initial values for your variables and that kind of stuff. And then on the loop, you put stuff that you want to happen over and over again. So in my case here, for these blinking pixels, the loop would be the thing that makes them change color, right? Because they need to keep changing color to the end of time. But the setup, it would be where I turn them on. All right. Oh, thank you. I'm glad it's interesting. Didn't know how. There's so many sides to this, and doing engineering is a little tricky because there are some things that are really exciting, that are cool, like building stuff and testing things out and seeing your new prototype work. And then there's other things like this, which are just typing and coding. And for some people it's very boring, and I totally understand. So I'm glad you find it interesting because it's going to be a bit of a roller coaster. We're going to have moments of just like, oh, that's really cool, and then moments of just, wow, really? So hopefully it goes well. So let's get started with the setup. So we need to call the whatever the function is that initializes the whole NeoPixel class. So we'll just do start NeoPixels, and then that's just using our strip object, and then we just call begin. All right, and then we probably need to initialize our buffer. And is mem set a thing? Cool. All right, so strip buffer. We want to set that to 0, and then the length of that is max Neopixels. I really hope that's the right way to do that. It's been a little while since I've done C. I've done a lot of Python, but and for reference, this code that I'm writing here is going to run on the little computer that I showed you earlier that's running this whole strip of lights. Later, I will use Python to write a program for my computer that allows me to send data to this computer, and then this code that I'm writing here will process that data and then display the lights as I direct. So now we got that set. Then we probably need to loop through and set the pixels. So I didn't learn a whole lot about this library, but I did take the time to look up some functions. Here, let's just loop through it for count. All right, count. I'm sorry, it's been a little while since I've done C. How many do we say? What is it gonna be? 16t. Yep. Equals 0. Count is less than max, and then our increment count plus equals 1, or we could just say count plus plus. Oh, that's cool. Programming is a neat skill. Really only perfected through practice. Okay, and then we want to do set pixel color. So this is the function that sets the color, and then we need to specify the pixel that we're talking about and the color we want it to be. So the pixel that we're talking about is count. So as you know, we'll increase count every time we go through this. So every time this loops, we'll have a different count value. And then we want to set the color, which we know is located in our strip buffer, at location count. I'm already butchering my words tonight. The Falcon was hard enough to talk and focus on that at the same time, and this stuff requires so much more concentration. So say initialize pixel color, and then show pixels. And then we're going to do strip dot show. And I believe that's right. Looking at my thing here. Okay, yep, looks good. So let's try this. If I do this and it works correctly, then all of these should just turn off because it's setting them to 0, which is basically black. Or in this case, because they're lights, black is just off because you can't show the color black. So let's verify. So verifying is Arduino's version of compile, and it looks like I messed something up. Ah, here's what I messed up. I told you I was doing too much Python. I used the Python uh, comment rather than the C comment. All right, save that and verify it again. Better. Don't forget your semicolons. And there we go. Looks good. All right, no errors. All right, and then we will upload, which will load everything to the Arduino. And there we go. Lights are out. So that worked. And now I'm not being blinded anymore, which was a good start. Okay. So next steps. Actually, we should probably verify this works. And I'm going to go ahead and define a few basic colors just for test. So even though it sends the green first, the way the library works, you can still specify the red value first. So let's just go ahead and define these colors. So red is the first two hex digits are full value. It's RGB. So green would be the next two. And then blue, oops, 0x FF. All right. Save that, and then let's just make it blue. And and we'll put blue as the default in this initialization right here. So now this is going to set the entire thing to blue and then start off with that. So let me compile this again. And then when I upload this, it should just make everything blue. So let's see what we get. Hey, kind of. Nope. Something messed up. All right, so it's hard to see, but the bottom here is kind of blue. I'm wondering if memset is not, if I'm not using that right, or it's not working the way I think it is. That would be about par for the course. Let's try it again. Maybe this is just a glitch. Neopixels are a little finicky, and so you got to make sure that you get those right. All right, nope. I know I have my settings right. There's legacy. Yep. I think it's this memset thing. If I just go in here, so we can test this out real quick by debugging. You know what I just realized is that even if this is boring, or not that interesting to watch, it's really helping me. It's going to help me a lot in just getting better at this, talking through things and forcing myself to explain it. Okay, that's verified. And then upload. And we'll let that upload real quick. Okay, yeah, so it is memset that's going wrong because now the whole thing's blue. So we probably just need to make our own initialization function. Set pixel buffer. All right, so we'll just set that down here. That doesn't need to be void. So let's just call it pixel buffer. And then color. Length. Oh, that's a keyword. Let's just do number pixels. Okay. So this is a function where we put in our buffer. We want to send in the color. Actually, I don't know if that's the way I want to do that. I just like notating it better that way. The color and then the number of pixels, and it will set every location in this buffer to this color until it reaches the full number of pixels. So to do that, I'll scroll down a little bit. Just a quick for loop. Zero. Count is less than number of pixels. Count plus plus. I don't like the auto spacing here for these loops that it's doing. Arduino perplexes me. I don't know why they try to be so different than like standard kind of formats. Or I guess it's probably just an opinion anyway, what's standard for me. All right, and then we want our pixel buffer at count to equal color. And so that'll loop through and set everything in that buffer to color. Okay. And then I did that the same way, whoops, as this kind of memset function. I will have to be careful with it because it's not memory safe. All right, now let's see if that works. And let's pick a different color. Let's just do green to see that it changes. They're already blue. And sometimes, I don't know exactly how this initialization works. All right, let's verify that. No errors. And then upload. And give it a second. Hey, whole thing's green. Okay. I don't know what's up with that mem set. I guess it... Oh, no. You know, I know exactly what was wrong with it. Memset is really for characters. It's used for strings, and characters use 8-bit numbers, and I was using 32-bit numbers, so it was overlapping a bunch of stuff in the memory. So that was not very safe on my part. That is a really bright green. I should turn these down to like half value. Let's try this. I'm just curious what these colors look like. All right. So it's really bright right now. Let's verify it and then upload, and there we go. A little dimmer. I don't know if you could see it on the camera, but it's definitely a little dimmer now. So that's a good start. It's at least not hurting my eyes as much. You know, as I'm getting older, my eyes get affected by bright lights more. Uh, yeah, it was bright, and I can actually show you that these can go way down. I'm gonna just one more time because it takes like 2 seconds to do this. Verify, drop it down to 20 or 20 in hex, and then it should drop way down now. See if this changes. Yeah, that's a little better. So if I work with these a lot more, I'm gonna have to be really careful because it's just gonna be tricky. I'm gonna need some really good camera equipment, or I don't know. That's gonna be hard to do on the fly. Either way, all right, that gets us started. This initialization will probably be moved out later because our setup is going to be more focused around setting up communication with the computer and things like that. But this is a good start. It just proves the thing works and we can change it later. Okay, let me caps locks I did. Let me put a comment here. 2-bit buffer to specific value. This is where I wish I was using some other IDE, something that would, put the deoxygen correct comment format in that I could just fill out. But this is what we get for doing Arduino. It was easy. All right, I'm gonna put it one here, main loop, and I'm gonna do this as setup. Just so when I save this, if somebody comes along later, I need to set up a GitHub so that you all can see it. Oh, it's much better? Okay, good. Thank you. I apologize too. I'm trying to watch the comments. It's a little harder to flip back and forth. I've got multiple computer screens up here now, and but I'll do my best. All right, we can take this out. This isn't necessary anymore. And then our main loop. All right, so this is the stuff that we want to do repeatedly. So one of the things we could do, let's just test this out to see that it works, is make some sort of loop that just shows these changing at a certain delay. So let's make the delay 500 milliseconds. So half a second is what that equates to. Delay is in milliseconds, so if you want to delay a second, you have to type 1,000, and that makes 1 second. And then let's do a quick conditional just to make sure the color changes. So if strip buffer 0 equals, let's just say red, then we want to change it to green, So we'll do memset, and then we want this one. So buffer, and then really just copy these arguments and change it. Or actually, it's already at green, so that makes that easy. All right, and I'm actually going to go ahead and, for the sake of running this, define the setup as black. Okay, here we go. And all right, setup is in black. Okay, so now when I start this, it will just turn off, which is what we want. Okay, so we're gonna set that to green, and then else if, and if it's green, we want it to do something else. So else if strip buffer 0 equals green, then if it's green, we want it to turn blue. So we will take this line right here and drop it right here and make this blue. Okay, finally. Else, and then we don't really need to check if it's red or green. We do need to check, but if it's blue, then it's just going to fail those first two and come here. Or if it's anything else, really. This is why we want this. It saves us from any unknown cases. And Arduino formatting, everybody. All right. And then if it's any other color like blue or something, we want it to go back to red. So you can see here what's going to happen is if it's red, it's going to become green. If it's green, it's going to become blue. And if it's blue or anything else, it's going to become red again. And then when it goes back around, it'll be back on red. So it's going to keep switching through them. We have to put this delay because, of course, this computer's running at 16 million clock cycles a second. If you don't put that delay, it'll happen so fast you can't see it. In order for our human eyes to see the colors change, we have to slow down the color change. Because otherwise this processor is going to do it as fast as it possibly can. Okay, so that looks good. And then we need to actually, and we probably need a function for this. Basically, what's happening right here should be in its own function. So let's go down here and then sets pixels to buffer. And then we'll go, and then we'll say void set pixels to buffer. Kind of a redundant comment there, but those are the best kind of comments. All right. And then I said it was going to be just doing this here, so we can just copy this and drop it here. And we don't actually have to pass in the buffer as an argument because it's already defined globally right here. So we already know what it is. So we will just do that. And strip is defined globally as well. So, and then this is going to be based on whatever we initialize it to. So I'm going to do current length there. And actually, now that I think about it, that's probably what we want to use everywhere. Max should just be the total max that we can do. But current length should be what we actually use to define everything. Okay. That looks better. All right, so that will go through and set every pixel to the appropriate color that's in the buffer, and then we can update it. So setting the pixel color does not change it. As you can see up here, even though we set the pixel color, we still had to say show. And that's because you set all the colors individually, but if you want them all to turn to the next color at the same time, then you want to go through and set all the colors and then tell it to show once all the colors have been set. And then it will update to the new thing. So that's what we're doing here. So we will update strip.show and then delay for human eyes. And then we'll say this is the changing color test. And we'll say test because it's going to get removed later. If we want to control it from the computer, we're not going to have something like this. But this should get us started. So because it's going to drop down to this else, because it starts off as black, right? It's going to come in here. Is it red? No. Is it green? No. Okay, it's something else. So let's go in here and change it to red. and then it will cycle through. So it should be red first, then green, then blue, and continue through that cycle, red, green, blue. So let me make sure I remembered all my semicolons. Array-bound is not an integer constant before a token. Nope, the error is something else. Constant before a token. Oh, it's not a constant. It wants it to be a constant value. I get what it's saying. Okay. All right, we might have to mess with that then. I didn't realize it would want a constant value there. All right, let's just set the buffer to the, well, that probably makes more sense actually. Yeah, okay, that works. Okay, so it's green right now. And by the way, I know that this is just, I'm just talking about a ton of stuff really fast here. But if you have ideas or suggestions, the whole point of this channel is for engineering collaboration. And I'm talking about this now because I don't want to get too far into this without pointing this out. It's all about collaboration and getting ideas from people, and I don't want this whole thing just to be my own ideas. So if you see something that I did wrong or something that I could do better, please point it out. Or if you have a cool idea that would make this easier or just cooler or whatever, like suggestions are totally welcome. So feel free, or ask questions if you don't understand something. I'll be happy to explain it. All right, so I'm gonna turn this on and let it load, and we got nothing. Okay, we missed something. It turned them off. The black worked, but it is not cycling through the colors like I expected. Show, which is a little weird. Current length. Well, anybody see the error? I don't see it yet. Hmm. I do not know. Everything looks like, I mean, but this is, I guess, always true. It looks like it should work, but it doesn't. So let's take the delay out and just try it again. And maybe this will, I don't know, maybe there's something weird with that. I don't think that's it. I think there's something wrong with my logic. Oh, you know what I didn't? I know what it is. Yeah. Okay. So I made this cool function that sets the pixels to the buffer, but I didn't actually call it anywhere. Spent all that time doing that. But if I want to actually use the function, I actually have to call it. Otherwise, it won't know when to use it. Okay. That's probably the error. Or at least it is an error, if there's still more. Okay, let's try that again. Let's program it. Hey, look at that. Switching color every half second. Cool, so that works. We've proven that we can do that. Now let's just do, there's one more thing I want to kind of test out. I demonstrated this in the video that I posted to Instagram and everything, but I want to write it out here just so we get kind of an idea. We're going to need our own loop function. And let's change this. I'm gonna turn down the brightness on all this too. The green is good, but everything else is so bright. These Neopixels draw so much power, and I've got like a 10 amp power supply to run just this little strip, which is more than enough, but oh, excuse me, it's it's still pulling like an amp of current. And if you can imagine LEDs pulling an amp, like the collective brightness of that is insane. Okay, so if we go into loop here, and what I'm going to do is actually go backwards. So unit 16t count equals current length minus 1, and we're going to count down. While count is greater than 0, count minus minus. Okay, so minus minus is another way of saying minus 1. It's just a shortcut that you can type in C. All right. And then we're going to do strip buffer count equals strip buffer count minus 1. So what this is going to do is for each pixel, it's going to set it to the pixel of the one next to it, or the one right before it. And by doing that, we can create the effect that colors are moving through the strip. Okay, so we don't want these mem sets anymore. We just want to set the, so that's green. So we just want to set the first item in the buffer to the color. Because if you notice from our for loop above, the only one we don't set is pixel 0. So pixel 0 equals green. And then we want to copy this for each of these sections here. And this one's going to be blue. And then this one's going to be red. Do they get warm? I haven't noticed yet. They're in this. I think I read somewhere that they might, but they're actually insulated inside this like clear rubberish sleeve right now. I can take them out, but I haven't for right now because it's protecting them. So I don't actually know. They're kind of insulated, so I don't know necessarily if they get super warm. I bet you I can look up a datasheet later that tells us though, or at least some reviews. Okay, so this one just sets the first pixel, and then every time the first pixel is changed, or the first pixel then gets applied to the second pixel gets applied to the third, and so on. And so what this should look like is they'll all be black, and then you'll see the colors walking up through here changing. So I'm actually gonna, yeah, let's leave it at that. Delay. Let's go ahead and make sure I've remembered all my semicolons. And then upload this. And then you should see them all go dark. And the beginning of the strip's way down here on the table. All right. I got nothing. It didn't work. So why didn't that work? Set pixels to buffer. All right, so I messed up my logic. Oh, here it is. Yeah, most of it is going to light. Some of it has to be going to heat, but most of it legitimately is going to light. So the double equal sign in C is a comparison, and if you use double equals when you're trying to actually assign that value to a variable, it's not going to do anything. All it's just doing is saying, yeah, that's false, yeah, that's false, yeah, that's true. What do you want me to do about it? Okay. Now that we remembered that, basic concepts. All right, cool. All right, here it comes. You'll see it when it comes into frame here. The colors are moving up the strip, and they're not quite too bright this time, so that should be a little better. There they go. So check it out. They're moving through. All right. So that looks good. So I think we're ready to get started making libraries and things for this. I apologize because I have to pick these up every time. to pull them into view. But yeah, that's pretty neat right there. All right. Thank you. I think it's cool too. There's a reason I started off with a project that uses lights because lights are pretty and attract attention. So, all right, let's just clear a couple of things there. All right, next steps. So we need to make a library that kind of initializes and handles all this on its own, and then we need a way to update that library with commands from the computer. So let's move this stuff into its own library and then go from there. So, oops, I apologize. I don't want a new sketch. Does Arduino let you like add a file? Or am I gonna have to go do that manually? Examples, preferences. I can't just click new. Arduino very much wants you to do everything in a single file, and I hate doing that. I really, really, really want to just put things in separate files like they're supposed to be. So I might have to do this manually. But, hmm, yeah, I'm not sure. I guess we could try it, see what happens, and then go from there. Could you arch it to consume a lighting script? What does that mean? I'm sorry, I don't fully understand that question. What does arch it mean? I'm gonna go here. I've got this. Let me Explorer, and let's Git trunk main, and then I'm gonna use Notepad++ to make some new files. Basically, this is a cheap way of doing it. Well, actually, I don't need to do that. I could just make them and rename them. All right. Lighting kit, and then we want that to be. I apologize. I'm doing this off screen because it's on my in my file explorer. Yes, I know. Changing that will make it unusable. And then we need a C file as well. I'm just seeing if I can basically open these files in Arduino here. I'm sure I can. To consume a lighting script. Oh, okay, design it. I see what you're saying. That's kind of the goal here. Is basically I'm going to set this up so that it uses a serial port to load basically a new profile to it, and that profile. So you can basically create it on, I'm gonna say basically a lot. You can create it on your computer, and then I'll have some software that converts it to the needed format, and then sends it over the serial port, which will load it onto the device, uh, and then it'll display that. I think that's what you're asking. And that way I don't have to write code every time I want to change something. Okay, I don't care that it's warning me if I change my file extensions, they could be unusable, which is true, but I hope I know what I'm doing. Okay, let's open .c. Oh, it opens up into, okay. C lightingkit.h. It opened up into a new thing. Did you see this? I've got the same thing open twice, but one has the tabs. All right, I guess we're closing that. All right, lightingkit.c, lightingkit.h. All right, since I'm just making this up as I go, if def no, if not defined, lighting kit H, then define, we just want to do the same thing, and whoops, and if. Okay. And then here we want to do include, if I can spell it, lighting kit.h. And we want to do the same thing in the main. Okay. So basically that'll function as kind of a layer between us and the Neopixels, and I'll be able to write a lot of helper functions that I'll use instead of the actual accelerate library functions to run that. Okay, cool. Glad I answered your question. I was a little worried there. Okay, so that looks good. Let's compile this and see if it works. Nope, error. It doesn't like include nested too deeply. I was curious if I could just throw it together like this in Arduino, and nested. Wow, it included it several times. Wonder how that happened. See the file path there that I put it on. All right. What caused that? It says it here in the .h file. Oh, I did that backwards. Okay. In the C file, I did the define, and here I did the whoops. I can honestly say that's the first time I've ever done that mistake. I've never done that before. All right, we're breaking new ground here. This is exciting. I like the uncertainty. Okay. Hey, it compiled. All right, so that means it included this file just fine, which is great, because now we can offload a bunch of functions here. So I think these first things first, these functions that we've already created here probably need to get offloaded because they're directly related to Neopixels. And basically anything that is directly related to Neopixels, I'm going to move over to this new library because it's another layer and it helps me isolate where things are and yada, yada, yada. So I'm going to put that in here. And then I'm going to have to move everything over that's important to that. So these values, these defines need to go to the header file. So, and just so everyone knows, oh, I forgot the spaces here. Well, actually, that just looks a little weird. I'm slowly learning my preferences as I do this. It's been so long since I've worked with Arduino. Okay. That goes, this goes, because it's part of the pixels. So that's going to go in here, because I don't really need it anywhere else. Save that. And then our Neopixel object is going to go land in that C file as well as our buffer. So really all of this needs to go in there. So I apologize if this is going really fast. Length specified by user. And I'm going to just be a little more descriptive. All right, like I said, I apologize if this is going fast. I'm just trying to reorganize everything really quick. All right, this is all just our test code. We don't really need any of that. I'm going to leave it here as a reference, but I'm going to comment it out. Okay, next thing's next. We probably want to write any other functions that we might need. So the update would be a good one. So pixels, and we're probably going to rename some of these functions with something. Okay, update pixels. I think that's a void because we don't really need anything, any arguments there. Whoops, not what I wanted. Back to the main, take this. Okay. Pixels in the accelerate library and displays them. There we go. Chat is a little quieter than usual, and I suspect that's because this is quite a big shift from Legos. If you have any questions or suggestions, once again, please just let me know. I am more than happy to answer them or take ideas. Okay, that's done. And then let's go back to main. What else needs to move? We probably need an initialization that does effectively this right here. Okay. If you're wondering why all of these functions, if you're wondering why I say void in front of everything, void means that this function does not return a value. Functions can typically pass a value back once they're done running, but because Neopixels are kind of an output thing, most of the functions you write from them aren't going to pass any values back. They're all going to be pushing stuff forward to the Neopixels. The Neopixels aren't sending anything back to the computer, so there's no reason to pass any values back. LK init. Is it necessary to put a color here? Probably. Yeah, I think we do. I think we need a length. Yep. Strip length. And then we need starting color. And so what this will do is allow the user to update those variables. So we want to do the current. Actually, we want to check. First things first. If current or strip length is greater than the max, otherwise we'll have a memory issue. Then we just want to return. Okay, so what this will do is if the specified length, say I send something saying, hey, give me, let's set it up for 60 pixels, and we only support up to 30, then obviously those extra 30 could be issues later. You know, if I'm telling it to change 60 colors, but it only can do 30, then things are going to get weird. So if it's greater than my max, then I'm just going to return and stop here. I'm not going to do anything else in this function. All right, so validate length. Then if that's true, we're good to go. So set length, and then we want to change our current length to whatever was provided. I don't have to check if it's less than 0 because I've specified that it's an unsigned integer anyway. And then we want to initialize colors. And for this, we want to do our mem set here. And so before I go any farther, I'm going to go ahead and rename most things in this library. You notice that for the init, I've named it LK for lighting kit. I'm actually going to do the same thing on all these functions. So if I'm ever calling these functions somewhere else, I know what library they're referring to. This is good practice if you're putting things in different files, is to start them off with some sort of initials, or some sort of mnemonic, or just some word or something that tells you what library it's coming from. Okay, that looks good. Now, and by the way, these lights are still running the whole time, even though I'm writing all this software, because everything runs standalone. You just have to program it to this board, and then the board just runs it by itself without help from the computer, which is what makes it really cool. Because it's really hard to get an entire computer into this Millennium Falcon. So, that being said, I'm not sure where I'm going to put the Neopixel board. Maybe it can go in one of the side in the cargo bays inside here. Okay, so that's good, and that means all my calling functions are going to be wrong, but that's fine. We'll fix that real quick. Okay, I'm set. Strip.set. All right, that's fine. It didn't actually end up being that bad. All right, and then we want to do LK memset Neopixel buffer. This is a mouthful. And Arduino, does anyone know if Arduino has autocomplete options? If I go to preferences, is there an autocomplete I can turn on? That will try and guess. I guess not. Huh. Okay. Well, for the buffer, we want to tell it to use the strip buffer. I don't even know that that's necessary if it's here and it's global. Yeah, it's global. We could probably get away from it. Let's take that out. Okay. So it's not working exactly. I had just done it that way because that's how memset worked, and I'm kind of emulating that, but there's no reason to really. Okay. Let's say I forgot what the arguments are. Color first. We wanted black, and then the number of pixels. I don't know that we need that argument either. Well, memset's tricky actually, because sometimes you want to set just a small portion, but I guess we're kind of setting the whole buffer. Let's change the name of this, because that'll be better later if we change something or add different functions. All right, actually, and then whole buffer, and then we don't need this, the number of pixels. And we know the number of pixels is going to be the same as current length, so there's no point in doing that. Okay, that looks good. What's next? I think we've pretty much got everything in. We need to declare all the functions in the header. So how this works in C is everything in these C files stays within these C files, kind of. Everything in these header files will appear everywhere that this header file is called. So in lighting kit, we call it at the top here. We call the lighting kit.h, and we also do that in main. We call lighting kit.h. So there's really no, so anything that we want to show up in, in main from lighting kit needs to be in this header file. Well, C lets us declare this, so we want to be able to use this function, set pixels to buffer. And actually, let's do it with the init. We want to be able to use this function init in main because we want to start up the pixels, and we're going to go to main when we start the program. So we need to declare it here. So let's go function declarations. All right. And this just tells the program that we are saying that there's a function called LK in it, and then it requires a strip length and a starting color. Okay? And then the, when the program gets here and sees the same name, same arguments, and then sees all this, it knows, okay, this is the definition. This is where I define what that function actually means. So basically, think of it like a dictionary. This was just saying there's this word, and then this was saying here's the definition for that word. And then in main, we can just uh, use that definition, some sort of init, and then it will go over here and see that it exists here, and it knows the definitions here, and it will sub that in where needed. That was probably a really bad ending to that explanation, but I didn't have a good start for it. I realized too, I forgot the strip.begin for our init function, and we're definitely going to need that. Okay. And then our starting color is what we should use instead of black here. Whoops. Okay. Now in main, we can basically get rid of all of this because it's just not necessary anymore. We've made it all redundant. And so we'll just let's leave the comments in. So we want to use LK init, and then we want to use the what are the arguments? The length and the color. We know the length is 30 because that's what I have on my strip here. And actually, I'm gonna go ahead and, even though I got rid of them all, I'm gonna throw another define up here. Test length, just so I have it easier to change in the future. All right, and then color, I want black. And it will be able to, it knows what black is because it's in our header file here. And actually, I should rename all of these too. These right here don't need to live in this header file. They don't need to be accessible. They can exist here. These colors though do, and I should rename them LK underscore and then the color. This is going to throw so many compile errors on the first try, just because I haven't, because I've changed so much in one swoop that it's going to be very, there's a lot of details that I probably missed. So, all right, that's a good start. And then anywhere we used a color as a default, I don't think we did it here any. Okay, yeah, we're good. And then out here in main, we need to change this to the LK. Okay, and there's no reason to show because we have a function in here for that, update pixels. So we need to get this into our header file. And that's what we need to do here. Oh, wait, that's recursive. We don't want to do that. No, don't define it there. I hear a car outside with a really bad belt in it. It's squealing like crazy. I apologize if you can hear that. Okay. Update. All right. Let's make sure we get our semicolons everywhere. And then we should probably go ahead and compile at this point because there's going to be a ton of errors and we need to make sure we catch them all. And for test reasons, I'm going to change this to green just so we can see it. All right. First error. Unknown type name, accelerate, Neopixel. In file included. Unknown type name class. I guess it didn't like that. Even though I included the header. Include library. What if I do? Does it just do the same thing if I do this? Yeah, it does. Weird. Oh, because it's a C file. I wonder if, well, no, I would think C files, I thought C files could still create classes. I might have to make this a C++. Dang it. Okay. Um, all right, give me 2 seconds. Maybe it has to be a C++ file. Just renaming something here. All right, let's open that back up. See if it comes back in. All right, that wasn't it. Oh, wait, it was. All right, forgot. Oh, okay. I forgot to do, I didn't think, I wasn't using these functions, so I didn't think to include them in the header file, but I definitely need to, because obviously, if they're being called, they need to be declared. I don't know why I thought that you could include classes in just C files from C++. I don't know why. That, I mean, it inherently doesn't make a lot of sense, but okay, let's try that. Wow, no errors. I'm surprised. That's cool. Okay, well, let's run it and see. It should turn green then. I think I set it to green in the main. Oh, that was a verified, sorry. Upload it. Nothing. Crashed. Okay, what we miss? Keyless in it. LK in it. Let's see. Here, strip.begin. Set starting color, which would have been green. Okay, that initializes it. And then what we called update pixels. So that would have called the memset, set everything. And then this would have been the set pixels to buffer, which would have set all our pixel colors and then showed it. And it didn't work. Let's see if it's a problem. I suspect this library may be having issues. So let's just start with that. That would at least, if nothing else, and then we can just return there. That'll take out some of that function, but it'll at least show if this turns off, then I think that means that the library is working properly. Yeah, it did. Okay, so the library is working, so the problem is my logic then. Well, that's good to know. That's usually an easier problem to solve. Okay. Does anybody have any idea what the error might be? Hmm. What is going wrong then? There must be something that's just not getting. The color, strip buffer. Where's that defined at? It's right here. Is that initialized? It is. Sec pixel color. Let's do this real quick. Let's just verify that it's at least getting this far. So what I'm doing right here is just putting in code to see there's an error somewhere. Logic's not working somewhere, and so I'm trying to see where that is. Uh, so we will use LK blue, and let's just set pixel number, I don't know, 25. That'll be near the end here so you can see it and show it. Okay, let's start with that. Upload. There it is. See it? Mr. Blue. There at the end. It's just that one. Okay, so we know that it's getting down there, that it's showing it. So what am I missing then? What's the starting color? Starting color is green. Oh, I wonder if this is getting set wrong. Current length equals max number of pixels, and then we update it here. Strip length equals current length, and starting color. Did we get that in the right order? Test length 30. Yep, that's right. I have one pixel down here at the beginning that turned green like it was supposed to, which is kind of odd. So I'm not sure why that is. Unless, okay, set pixels to buffer. And then strip dot show. That should have worked. That really should have worked. So what am I missing? Well, this is exciting times. So we know that worked there. Let's take that out. Put this here. Just to see that this function is working properly. Okay. Let's try that again. Upload. Same LED should be blue. I probably should have made it a different LED so I could see it happen. All right, that's still blue, so yeah, that means nothing. Let's make it number 26 instead. I should set up the serial port. That would probably help me debug this a little bit. All right, we should see this move. Nothing. Okay, that's interesting. So set pixels to buffer is not working. Or we're not getting there at least. Update pixels. Set pixels to buffer. Which means init is not either not finishing or there we go. No. Weird. Really, really weird. I'm sure there's like a super easy explanation to this, but I'm missing it right now. Um, don't know if anyone has any thoughts. Well, if it was easy, everybody would do it, right? All right, let's just take this out then. Is it something with my calling function? I don't know if you need a. I wish Arduino could debug as well. I don't know that that's an option for me here though with this hardware. It's very specific. All right, let's just see what this does. Maybe I'm just not even reaching that function. If this turns the whole thing green, then that means it does. Okay. Wow. So I'm just something I'm doing is not even reaching this. Probably because I just used the definition here. Dang it. That was so easy. I don't know if anybody else caught that. Using the definition keywords there. Just specifying things. All right, we can remove these two. That's probably good. And then let's go back to main here and change the color so we can do something else. Let's make it blue. All right, this should get us started on blue. So let me do that, turn it on, run it, and the whole thing should turn blue. There it goes. Okay, cool. So we're working. Next thing I think we're going to need in this library is a function to set a specific pixel. Okay, set pixel color. And then we need the pixel. And we need the color. All right, and then let's take this function and drop it in here. All right, and then changes a single pixel color in the buffer, which is exactly what we want. And so all this is going to do is take, well, I guess we need to validate a few things. If pixel is greater than or equal to current length, then that would be off the page, so we don't want to do that. Then we just return. And actually, that's probably all we got to validate. Let's validate the index. And then set the color. So we go to strip buffer. And then we go to that pixel location. And we set that equal to the new color. And then I don't actually have to update this to the library because you see it happens there every time I update the pixels. So that should be fine. So now if we go into main, we can take this function, set the color, and do it here. And let's say pixel 0. Actually, let's do 25 because that's one you'll all be able to see. And we'll do, what does it start at? It starts with blue, so let's do red. And then just to demo this works, I'm going to add a little bit more test code in here. Red, and then back to blue. So this will change a single pixel in this whole string. The whole thing will get set to, let's do green actually, so that it's different than the other two. And then we'll see a single pixel, change color here. So let's verify that and then upload. And so right in here, I think this is number 25 or this one. All right, the whole thing went green, and then nothing happened. And the reason nothing happened is because we have to update our pixels every time we change the color. And I didn't do that. So fail on my part. Okay, let's verify that again, and then we do this. There it is. So they're all green, except for number 25 here, which is flipping between red and blue, which I think you can see there. So yeah, that that works. Our library's coming together, and I think it's good enough now that we can stop doing this and we can move over to our serial terminal and try and make that work, which is going to be a little tricky. That's going to take some string functions and whatnot. So we can get rid of this extra little bit here and check it out. It's still going, still blinking away. So let's get rid of that. That's cool that we can actually change individual pixels on the thing now one at a time. All right, so we want to get, man, we're going to probably need like a command processing library too. So another library, because we want to get stuff from the serial terminal and then uh, uh, parse that, and then from those arguments, change the, make the correct decision here. So, and change the color as appropriate. So I guess we need to figure out how to do that. First things first, I probably need to figure out, um, I forget how Arduino does that, what the functions are. So let me Google this over here in my other screen and look at the Arduino reference. All right. Let's go to serial. Fine. So you have read bytes until, read string. What does read string do? Reads characters in the serial buffer into a string. The function terminates if it times out. String inherits from the stream utility class. Okay. What does it know? The only question I have, it doesn't tell me what it's looking for. So typically these serial kind of libraries, if they're reading and they say read string or something like that, they're reading until they find a certain character. And I don't know what that is. Or it may just read until the buffer is empty. Let me see what my other options are. Read bytes until. Oh, okay, reads into an array. This might work better. So there's a read bytes until, which will read them until it either times out. I don't even like that because the thing about timeouts and stuff is they're kind of, these functions, they're kind of blocking. So maybe we just use the read byte. First byte of incoming serial data type is an int. Yep, we could do that and then cast it. Okay. And then find exactly what we're looking for. So we need a command buffer basically. So let's set that up. We'll just do a character buffer. I know C++ has like string stuff in it. I'm used to doing it in C, so I'm probably going to do that here, but I might convert it later. And then, as usual, once we prove it works, we'll move everything into another library. I'll make that black from the next one. So command buffer, What's our command buffer? How long should it be? 64 bytes? That sounds good. Good round number. All right. And then we can actually here, void reset command buffer. And we'll make that void. Okay. And then we just want to do a mem set there. Set command buffer to 0. And that's link 64. I know it's bad practice just to type these numbers all over the place without making a constant for it, but it's going to move later anyway. All right, excuse me. Okay, so now that that's there, we can do that. We can call that here. And then we need the serial object. So in this, we need to sketch, include library, and this should be a library, right? Maybe. Oh, you know what? I might have to use the accelerate libraries. I thought the existing Arduino ones would work though. Or maybe it looks like it might be included already. So we can just do it here. Reset the command buffer. Serial? Oh, it is. Okay. And then do begin. And then, so this particular device, because of FPGA and all that, it's typically when Arduino serial ports run at 9600 baud by default. That seems to be good for their speed and how they work and everything. That is not true with this FPGA. It runs at 115,200 baud. So when you send data, it's going to send 115,200 characters per second. So, and in a given word, like the word book is 4 characters, and it will send those 4 characters at the rate of that many per second. So it'll be over in the blink of an eye, right? And that fast data rate is really useful for us because we like to cycle Neopixels really quickly. Sorry, let's hit the mic there. Okay. Let's look at this and see. Uh, what am I missing? Sorry, my mind got a little distracted there. Serial begin, and then in the loop, we probably want to get next character, and we probably want like a global variable telling us that. So uh, bool command received equals false. How do you do it? Is it all caps? There it is. Bool, or not a bool. We want the command index. We can just use byte for that. Index equals 0. And then when we reset the command buffer, we want to update these to the default values. So we're going to use these as flags and pointers to keep track of the command as we receive it. Now, this is a really roundabout way of doing it, and I'm sure Arduino with C++ has an easier way. But like I said, it's just the way I'm used to, and I like to write the libraries for these things. Okay. All right, so then we need to use the serial.read. And does serial.read have a timeout? It doesn't, but it just returns -1 if there's no value available. All right. So we're gonna need the received data equals serial.read. And then if it's -1, we don't care. So if received data is greater than or equal to 0, that means it was a legitimate thing that we received. Then we want to put that in our buffer. And so we'll do void add to buffer. And actually, we're going to make the Boolean out of this, just because it seems like this is a good way to do this. So we'll make it return true if it's received the full command and false if it hasn't. And the way we'll know that is we'll specify a termination character of some sort. So int received data. Okay. So then we'll want to, I'm going to make our termination character the new line character. And I'm going to, so for this, I need to append this into the command buffer where it exists. So command buffer, and then we'll use our current index, command index equals received data. And we know received data is an integer, which could be, this shouldn't happen, but it could be bigger than 8 bits, which is bigger than a character. So we're going to have to make sure that we take that into account by anding it with FF to make sure it's 8 bits. And then I think we'll just, to be sure, we'll cast it as a character. And that should make that not spit out any warnings. All right, and then once we add something to the command buffer, we want to increase the index because next time we receive something, we want it to add to the next spot. So command index plus, and then finally, we want to check for the end of the command. And honestly, we should probably do that now. Well, no, we'll do it at the end because we want to make sure it still exists in the command buffer. So if command buffer command index equals, and then our new line character, then we want to return true. True. Here, I'll separate these out so we know what's going on here. Otherwise, return false. And buffer and variables. Get next character and check for full command. All right, and then down here, get next character and check for full command. I can tell this is going to be an exciting video. Just me typing here all the time. Okay, excuse me. So that looks good. What's next? Let me make sure I can still see everything over here. Yep, looks good over there. Just making sure my stream still looks good. Okay, now um, that should receive and let me know when I get a full command. And we should test that a couple of ways. Every character it receives, it should send back. Let's do that too. Serial dot, is it sent? It should be, I believe it's either write or send. Write. Sorry. To send the characters representing the digits of a number, use the print function instead. Interesting. So it has print. But we can use write, I believe. Write. And then we want to use received data. Cool. All right, that should be a good place to test it. And then when if it returns true, we want to do something to let us know that. So we're starting off by turning the whole strip black, and let's turn on an LED if that works. So we know, so if received data is greater than 0, we're going to go through and add it to the buffer. Which add to command buffer, and then received data. And then this has to be in an if statement as well because it's returning a Boolean. So if that comes out to be true, we do one thing. If it's false, we do something else. If it comes out to be true, then let's turn on the light or change the color or something. Here we go. Oof, spacing. All right, so we'll set everything will be green and we'll turn that, or everything will be black and we'll turn the one red if we receive it. Actually, let's make it green because green means good. And then there's no point in having this delay anymore because it's only going to change as fast as we send it data. Okay, I think that all looks good. It's a lot to debug in a single run, so bear with me. It compiled. Okay, that's a surprise. I'm just not used to stuff doing that. And then let's just run it and see what it looks like. This will be a good start for us too. It should, okay, cool. So the lights went out, so that means it initialized probably correctly. I'm gonna bust open the serial terminal here and bring it to the middle. 115,000 baud, new line at the end. Yeah, let's do that. And let's just send it something test. And it should send this back. So we should see it appear down here. And then it should also light up the LED. Okay, it sent it back, but it didn't light up the LED. So it means it didn't get the new line character or it didn't do the right thing because of that. But it did send test back. So that's optimistic. Huh. Okay. So it is reading and sending the characters back. So that's good. No questions? All right, cool. Does anybody know what I did wrong here? Add to command buffer. It should highlight that every time. I wish it would. If command buffer, command index. Oh, you know what it is? We're adding to it the command buffer and then increasing the index. The index no longer points at the received character. So we should just do um that would yeah, let's just try this. If receive data equals new line, then that should do it. All right. Upload. So I got the LED strip here. Looks good. All right, let's do the test again. And then if this works, it'll light up a light here when I click test. Send, and there's the light. Awesome. Awesome, awesome, awesome. So now we're reading data. We're able to distinguish when commands happen. Um, so that's cool. That's really cool, actually. All right. There is a slight logical error here. Not really, because we haven't done anything with it yet. But once we realize that our command is good and we process it, then we need to reset the command buffer using the function down here. Otherwise, it will keep uh, after that, it'll start getting really weird. It'll get hard to process because it'll just keep filling up the buffer even more. So we definitely need to do that. Let's see. And I know we're getting close to the end here, but this is good. We've made good progress today. So I need to come up with something really quick that we can use just to basically set colors, and then I think I'll be good for the day. Uh, Good to go. So what's a good way to do that? Hmm. I'm trying to think through this one. Okay, let's do. Let's see, get. So how do we get the? I forget how to do this. Get number from a character array. Oh, there's yeah, string too long is an option. I assume if memset works, that Arduino includes the string.h file automatically. All right, we probably need a function for this. Bool process command. And the buffer's global, so we don't need any arguments there. Probably gonna need a temp buffer to put the first. So what I'm thinking is the first number being the position, the second number being the color value. So we need to create a temp buffer. And we could just say that this is, we know the number is not going to be longer than like 4 digits. Well, it could, if it's the color, actually, it could be pretty big. Um, okay. Yeah, 16. That should be enough digits, yep, for the number. Okay. Set. If you're wondering why I memset the strings to 0 all the time, it's because 0 is the null terminator. And so it's basically setting every digit on that string to the null termination. A null terminator signals the end of a string. So by doing this, I'm signaling that basically the first character it reaches that's 0, it's going to think that's the end. And by setting them all to the end, it's never going to get anywhere. It's just a safety thing. Okay, excuse me. Whew. My voice is getting tired. I apologize. We'll be done here hopefully soon. All right, so so once that's set, then let's copy into the temp buffer. So temp uint8t temp index equals 0. And then while loops, temp index, no, command buffer dex is not equal. Nope, I want a character, and I'm going to put a semicolon between them. Then we copy it over. All right, so then temp buffer of our temp, using our temp index. Interesting spam. Please don't do that. You're getting banned as soon as I figure it out. Nobody likes spam. Okay. Temp index. This equals, nope. Command buffer. Temp index. I apologize. That was really slow to get to just that easy statement, and then we need to increase the index. So what this will do is copy over that number to the second buffer, which will let us basically have that first number in this temp buffer, and then we can convert it. Easy enough. Okay. And then we'll have to increase the temp index again if we land on that one character, so we'll want to move past it for the next thing. But all right, so that will be our position. So that should be 16t. So 16-bit LED, or I guess just pixel position, equals string to int, and I believe we give it the string. So that should just be temp buffer. I think that's how that function works. Whoops, let me Google it real quick, just make sure. It looks like that's not, it doesn't have that. It's only string to long. So there's no strtoi. It's just, where is it? To L. Yep, that's a thing. Okay, that's okay. It'll work here. Okay, and then we got to do the same thing again while we're waiting for the new line. So we need to mems the temp buffer again. Once we do that, I should probably go through and comment this whole function again just so I remember where everything is. And we're not going to reset the temp index because we need to stay where we are reading from the existing buffer because it's the next item. And what we're waiting for is we don't want this to be a new line character. Okay. So now that should be good enough for that. And then we need another variable, the color. uint32t pixel color equals this exact same thing up here, the string to long conversion of that. Okay. And then we set the pixel color. All right, that was a really dense function. I apologize. This is one of those things that is a bit complicated, but I think it looks like it's going to work. I say that now. So let's then call our function for setting a specific pixel. This one. Really, both of these. We need both. Whoops. All right, process command. And we'll put that there. And then we need to change the arguments here. So this will be pixel position. And this will be pixel color. And then update pixels. I think all that will work. I don't know. We might have to get a little creative, but at least now we have the serial communication, so we can send data back and forth. So it makes it easier to debug. Okay. I guess we got to test it. So rather than set the color, if the command is good, we will process the command, and then we'll need to reset the buffer so we can do it again. Okay. Yeah, that might work. Let's see if it compiles. Errors, always errors. Too few arguments for string to, oh, I just didn't even bother understanding how that function worked. That's on me. Base. All right, let me look at this. I'm trying to understand how this function works. Oh, interesting. I may not have had to do this super complicated way. Okay, that's fine. So one cool thing we can do here with this function is that we can actually change the base, which I'm going to do. I'm going to make it 16 so we can work in hex. And then it actually also needs a return pointer. And that's going to go there. So basically it's going to read the string, find the number, and then return us a pointer to the item after that number, which may mean some of this work I just did was actually kind of redundant. So, you know, it happens. And then just to be weird, I'm not going to do base 16 for this first one. Okay. That's going to work. No. Oh, I got to move this up if I'm going to use it again. Still no. We'll get there eventually. Yeah. Needs to be a pointer to a pointer. Okay. Wow, not even any warnings. That's weird. Okay, so now I should be able to send a number, semicolon, another number that will set the value of a certain pixel. So that's working. So let's upload it. It should turn everything off once it uploads. So you'll see the green go off. There it goes. Okay. Let me open up my serial terminal here. And we're going to set pixel 25 to red. And so theoretically that'll process and set that same pixel that just turned off to red. Oh, we'll see. Nope, didn't work. Okay. I mean, that's to be expected. No surprises there, really. I think we can debug this pretty easily, though, since we have the serial commands in now. So serial.write will take a string or a buffer and a length, which is fine. So let's just, I suspect these temp buffers are getting messed up. So let's just go ahead and send them back as part of the exercise. So serial.send, no, write, and we'll do the temp buffer. And we'll do the same thing down here after this one. So where I'm splitting these two arguments up, I'm sending the arguments back. So theoretically, I can, oh, I know what I did wrong. Okay, well, this might demonstrate it then. And then upload. Now we know that's not going to work, so there's no point in holding that up. Okay, let's do 25, FF000. There. Okay, so you can see that 25 responded, so it got that number just fine. But it didn't get the other one. And the reason for that is when we reset this temp, or we didn't reset this temp index, but we really need to for this one. We need another pointer because we're using temp buffer again and starting from the beginning, but in the command buffer, we're starting in the middle. So we need two different pointers, two different indexes. So this is a terrible way to do this, but I'm going to do temp index 2. X2 equals 0, and then that's the one that it'll write to. And then we're going to have to increase both of them to make sure we don't overwrite anything. There we go. Okay. And then, well, I don't know why I'm holding that up yet, but should verify this and then upload, and I think we'll be okay. Let me start the serial terminal. All right. Pixel 25 is becoming red now. Hey, it worked. Okay, cool. So then if I do pixel 24, should become, let's do green. I don't think I need to capitalize it. So that means the one below it should turn green when I do that. Hey, awesome, awesome, awesome. It works. Okay, cool. Our command structure is working. So now I can individually, through the serial terminal, change the colors, and I don't have to change the programming on the Arduino at all. So now I can write a Python script or something on my computer to control the colors. And I can control it as fast as I can run the serial port. Okay, there's no reason to debug that stuff. I need to take out those debug strings. Let's just do a random color here. Let's just do white. Just so you can see. So the last pixel here is going to turn white, which is going to be super bright. Oh yeah, there it is. It outshines everything. Awesome, awesome, awesome. Okay, so that's what I wanted to do tonight. Really, that's it. I wanted to demo that working, and we're kind of running towards the end of time anyway. I'll move everything to its all the command stuff to its own library next time, because that'll be some more organization, and I want to think about that some before I do it. Um, Anybody that's still watching, I'm so thankful for you sticking with me this long. I know this has been kind of slow and everything, but it's building to something. So I appreciate you watching and just listening in. Think that through. Like what this command structure should look like, because we don't just want to set, like one pixel at a time, but we may want to set a string of pixels or cause some effects or something. We need to figure out how to do that, what this command structure should look like to do different things. And eventually we're going to want to load a whole file to it. I've ordered some SD card slots that will connect to this thing, and we can use those to store a file of the playback data or something, and we can load an entire playback to this strip in one go, and then it'll just run that. That would be ideal. But this just demos that our serial is working, that we can directly talk and control the Neopixel strip. So that was a lot of fun. Let me exit out of this. You're gonna post this on Git? Yes, I absolutely should. There actually is an Inicus project GitHub, um, which I'm not gonna pull up right now, but I'll start linking that below because I'm gonna need it. There is a GitHub. It actually has a couple projects on it already, like a matrix multiplication library for C# and something else. But yeah, we're gonna start putting stuff up there so that other people can look at it and contribute. But in the meantime, think through how we should do this command structure, because now that we've proven that it works and that we can get these characters and these variables and everything, we need to start organizing things, and we need to come up with an organized command list for how to control this thing. Because just setting a pixel at a time is awesome, but I think we want to set multiple pixels at a time and other stuff, and we want it to be fast, so we need to limit the number of characters, keep the packet sizes down. So how we do all of that's going to change. I have some ideas, but we'll think it through, and yeah. So Sunday, I'll be back same time, or not same time. I'll be back at 2 to 2:30 p.m. and go from there. And yeah, we'll build on this, and we're going to make this really cool modular lighting system. And once it's all done, once we are satisfied with everything working, we'll put it in the Millennium Falcon. So sweet. Thank you all for sticking around, and have a good night, and I'll see you Sunday.